Okay, so we're going to use a quadratic formula to solve x squared minus 6x plus 11 equal to 0. This time a is 1, b is negative 6, c is 11. So we'll have x equals, we're going to do negative b, which means I'm going to do the opposite of b. So my negative 6, the opposite of negative 6 is going to be positive 6. So we've got, or if you need to write negative parentheses negative 6, you can do that. Plus or minus square root of b squared. So it's very important that you use parentheses if you're squaring a negative number. That can, if you do not include parentheses in this step, then your answer is going to be wrong because you'll probably do it wrong. So you need to put your negative 6 in parentheses. Minus 4 times a, so 1 times c is 11, all over 2 times a is 1. So we've got x equals positive 6 plus or minus the square root of 36 minus 44. So negative 4 times 1 times 11 is negative 44. And then 2 in the denominator. So now we have x equals 6 plus or minus the square root. 36 minus 44 gives me negative 8 all over 2. Okay, this needs to be simplified. I know the negative I can write with just putting the I on the outside. So, excuse me. Okay, so we have x equals 6 plus or minus I comes out. And then how can we write the 8? Let's go ahead and put the 2 down there so we don't forget it. How can we write 8 so that there's a perfect square that I can remove? Well, I can write 8 as 4 times 2. So that gives me, and I hope is this showing up? Okay. So this gives me x equals 6 plus or minus square root of 4 is 2, so you've got 2i times the square root of that 2 stays inside, all over 2. This definitely needs to be simplified. So you've got x equals 6 plus or minus, 6 over 2 plus or minus 2i square root 2 over 2. And we can simplify that as 3 plus or minus, these 2's cancel, I square root 2. Again, if it's a paper test, you can stop here. If it's My Math Lab, or sometimes if it's multiple choice, you'll have to make sure that you can recognize it as a solution set. So you'll have 3 minus I square root 2, comma 3 plus I square root 2. Example 4, part C, we're asked to use a quadratic formula to solve 4x squared plus 9 equal to 12x. Before I apply the formula, this needs, excuse me, this must be written in the standard form, meaning it's got to be the x squared term, the x term, the constant, and then the 0 last. So we're going to subtract 12x on both sides. So 4x squared minus 12x plus 9 equals 0. And yes, there are other ways that this can be solved, but we were specifically asked to use the quadratic formula. So we can see that a is 4, b is negative 12, c is 9. Applying the formula, we'll have x equals negative b, which is going to be positive 12, plus or minus the square root of b squared. So again, you have to use parentheses, negative 12 quantity squared, minus 4 times a, which is 4, c is 9. This is all over 2 times, and a is 4. Okay, so we've got x equals 12 plus or minus, we're going to clean up the radical on the inside, and let's go ahead and put that 8 in the denominator. And I'm just checking to make sure that it's showing up for you on there. Okay. All right, so inside the square root, we've got, this is going to be positive 144 minus 4 times 4 times 9. Take a minute and figure out how much that is. All right, 16 times 9, I believe that gives you 144. Okay. So inside the square root, we've got 144 minus 144, so we've got square root of 0. So x equals 12 plus or minus the square root of 0 over 8. Okay, we talked about this earlier, but I always ask people, what is the square root of 0? And sometimes they have trouble telling me. The square root of 0 is 0, because 0 times 0 equals 0. So we have 12, and then plus or minus 0. I don't even need to write this. This is redundant. Plus or minus 0 can just be left blank. So we just got 12 in the numerator over 8 in the denominator. Simplify that. That's, they have a common factor of 4, so 3 over 2. So x equals 3 halves, and set notation would just be 3 halves inside the curly braces. And that's it. So in example 5, we are asked to solve an application dealing with a quadratic equation. We have a ball that's tossed straight upward. Its height h in feet at time t in seconds is given by the equation h equals negative 16t squared plus 40t plus 6. For how long is the ball in the air? Okay, so this is just a very basic question. When you throw a ball in the air, it's going to go up like this, and then it's going to make like a U shape and come back down. In order to determine how long your ball has been in the air, you need to think about what do you know about the height. Well, when the ball reaches contact with the ground after it's been in the air, what is its height from the ground at that point? You can think about that for a moment. Pause if you need to. After the ball has been in the air and it's back on the ground again, its height from the ground is 0. And notice that's how h is defined. H is defined to be the height in feet. So in order to solve this, let's let h equal 0. So you'll have 0 equals negative 16t squared plus 40t plus 6. Alright, and you can use any of the methods that we've discussed if they are applicable to this problem to solve this quadratic equation. I'm going to go ahead and go with the quadratic formula because I know it's going to work. In order to use the quadratic formula, I need to determine my a, my b, and my c. Alright, I know that a is negative 16, b is 40, c is 6. So I can put these directly into the formula. X equals negative 40 plus or minus the square root of 40 squared minus 4 times negative 16 times 6 all over 2 times negative 16. So we have x equals negative 40 plus or minus the square root. All right, in the denominator, 2 times negative 16 is negative 32. I like to go ahead and put that step in before I get too bogged down with this piece, just to make sure I don't forget to include it. It's easy to forget that. Up here, what do we have? I would probably pull the calculator out at this point. 40 squared, I'll pause the video and I'll let you see it. I'll let you take it from here and then we'll compare. Okay, so inside the radical, you should have gotten 1,984. Oh, and by the way, I've got x just out of habit. What variable are we really solving for? They're asking us how long, so we're solving for t. So really, I should have a t instead of an x. Okay, so we've got negative 40. Plus or minus, and then we need to take the square root of 1,984. And you should have got I'm sorry. You should have gotten 44.54 over negative 32. All right, so now this, make sure you understand this is giving you two possible answers. The plus or minus is two different pieces that you need to do. So you've got negative 40 plus 44.54 all over negative 32. All right, that answer should be giving you positive, I'm sorry, that answer is giving you negative 0.14. I don't remember if they were specific about how I needed to round. Let's take a look real quick. No, we weren't told how to round this, I don't think. At least not in your notes, you weren't. All right, and then so this is part of it. This is the first possible answer that we're getting. The second one we'll get if we do t equal negative 40 minus 40. Tell I'm getting tired now. Negative 40 minus 44.54 all over negative 32. So in this one, you'll get t equals positive 2.64. Okay, so that should not be surprising to get two possible answers. If you anytime, I don't think I mentioned this specifically before, but when you're working with a quadratic equation, that exponent of 2, that's the largest exponent that you have with a quadratic equation. This indicates that you're going to expect to get two possible answers. And that's what we have. We have two possible answers. Do both of those answers make sense in the context of this problem? We were asked how long is the ball in the air? Well, that answer does not make any sense. This is telling you so it's 0.14. Negative 0.14 that would be like having to go back into time. That's not going to make sense. So the negative answer we're going to toss out. 2.64 makes perfect sense. That makes perfect sense that the ball was in the air for 2.64 seconds. So our answer, 2.64 seconds. Okay, so for example 6, we have one leg of a right triangle is 2 feet longer than the other leg. If the hypotenuse is 6 feet, find the lengths of the legs. So you should have read the notes preceding example 6, and you'll see that it discusses the Pythagorean theorem. We are working with a word problem involving a right triangle, so most of the time you're going to want to use the Pythagorean theorem in that situation. So let's draw a picture of what we have. Here's my right angle. All right, the legs of my triangle are going to be the two shorter sides. We generally use the A and the B to denote the legs. C is the hypotenuse, the longest side. It tells me that one leg is 2 feet longer than the other leg. So as we're reading through this, we need to be thinking about how to choose our x. X needs to be something that we know very little about, perhaps nothing about. We also may need to express other quantities in the problem in terms of x. So it says one leg is 2 feet longer than the other leg, and then the hypotenuse is 6 feet. So what would you think about how you want to choose x here? They told us that one leg is 2 feet longer than the other leg. So we know something about one of them, the other one we don't. Let's think of it in terms of shorter leg versus longer leg. Which of those do we know the least about? Okay, we know less about the shorter leg because the one that's 2 feet longer is going to be the longer leg. So we're going to let x equal the shorter leg. How can we express the longer leg? It said it was a difference of 2 feet. So we'll say x plus 2 is the longer leg. All right? So in the triangle, we can go ahead and fill those values in. So we know that we've got a leg of x. Since I drew mine to be a little, I think that looks a little bit shorter. I don't know, it might not be. Maybe that should be my, let's do it this way. Maybe that one's a little shorter. I didn't draw my picture very well. Maybe I should have a clearer short side. Okay, so now I can say this is my shorter leg, x plus 2 is my longer leg, and they told me the hypotenuse is 6. So once I have the values in, I can go ahead and put them into my Pythagorean theorem. My Pythagorean theorem, again, is a squared plus b squared equals c squared. So we're going to put in the two legs for the a and the b. So we've got x squared plus x plus 2 quantity squared equals 6 squared. And we just solve this for x. So x squared plus, make sure that you know when you get to this step that you realize you have to FOIL this because you've got an addition on the inside of your parentheses. You cannot just square each piece. The rules for exponents work if you've got multiplication on the inside or division on the inside. This has to actually be expanded out. So you have to say x plus 2 times x plus 2. Okay, 6 squared would be 36. So we'll FOIL. I'm going to let you continue with this and then we'll compare. Okay, so we've got x squared plus, you're going to FOIL, x squared plus 2x plus 2x is 4x, plus 2 squared, excuse me, 2 times 2 is 4. I want to subtract 36 here, set it equal to 0. So I have 2x squared plus 4x minus 32 equals 0. So it could be that this may factor, or you can use the quadratic formula, or you can complete the square. You can choose whichever method you want to try to use. Let's practice completing the square. Let's see what happens. If you remember when we discussed completing the square, remember we said that the x squared term must have a 1 for a coefficient, and this one does not. So we would start, if we complete the square, we would divide everything by 2. So that would give us x squared plus 2x minus 16 equals 0. Okay? And then you want to add 16 to both sides and put in the two blanks. Okay, so let's scoot this on up. Okay, so I just chose the completing the square method just to give us a little extra practice with that because that's probably what you're least familiar with. Okay, how do we fill in the blank again? You need to take half of the middle term, 2. Half of 2 is 1, and then square 1. Well, 1 squared is equal to 1. So you put a 1 in this blank, and you also put the same number in the blank on the other side just to keep your equation balanced. All right, and then factor. Remember, this needs to give us a perfect square when we factor, and then you've got 17 on the other side. All right, so just maybe pause the video for just a second. Go ahead and see if you can factor that and see how far you can get. Okay, so this should factor as x plus 1 times x plus 1. All right, because 1 times 1 is 1, and then 1x plus 1x is 2x. And notice you have the same thing inside both sets of parentheses. That is a requirement for completing the square. And I think I may have scaled that up too high for you. Sorry about that. Okay. So you've got the same thing multiplied by itself. So that allows us to write this as x plus 1 quantity squared equals 17. Now we can use the square root property. So we'll take the square root of both sides. We'll get x plus 1 equals, remember to do plus or minus the square root of your constant. All right, and then you can subtract 1 on both sides. So x equals negative 1 plus or minus square root of 17. Okay? Because this is a geometry problem, it might be better to use, probably would be preferable to use decimals. So let's see what this gives us as a decimal. might want to pause this and just grab the calculator really quickly. I'm going to do the same. Okay, so typing this into the calculator, I came up with x equal, when I added them, -1 plus square root 17, I got 3.123. Again, the problem was not specific about how to round my answers or how far to take my decimal places, so I just did 3 decimal places. Or, when I subtracted -1 minus square root 17, my answer was -5.123. These are really approximations. They're not exact because these are irrational numbers. So we'll just say they're approximately those values. Now, do both of these answers make sense in the context of this problem? Well, if you recall, go back up, think about what we're doing here. We're solving for x, which is measurements of the lengths of a triangle. So a negative answer is not going to make any sense in the context of this problem. So that means we can eliminate the -5.123, and our answer is going to be the positive 3.123, or x equals -1 plus square root 17. So that's the approximation, and this is the exact value. Hi guys, it's Miss Lewis again. There are actually 2 correct answers to this problem. We were asked at the beginning to find the lengths of the 2 sides, or the 2 legs. We found x to be 3.123, and if you recall, the second leg was x plus 2 feet, so our second leg would have length 5.123 feet. So there were 2 correct answers to this. The homework, the directions should be more clear about how to give your answer, as far as exact form or decimal approximation. Okay, but that's it for that question. Is that the last one of the section? Okay, yep. So that completes section 1.7, which is the solving quadratic equations. There's a lot of material in this section, so please make sure that you spend plenty of time practicing it.